Hello, my favorite math people. Okay, so today is the remainder theorems and factor theorems. There's a lot going on in this lesson. What you're going to find is I'm reviewing a bunch of these little things that I have to teach you, and you're like, why are we doing any of this? And you're not really going to figure it all out until the end, where I can do a question and actually put all these little things together. But we kind of have to go through a process of just teaching you a bunch of little things first, okay? And it's fun. And actually, some of it you've already done. The first thing we're going to do is long division. And we actually have tackled long division. Just, it's kind of short long division, but we've tackled long division when we were looking for horizontal asymptotes in our rational equations. Or do you remember when we wanted to convert it so that it looked like that a over x minus h and then plus k? What we did there was polynomial division, okay? So that's actually where we're going to start today. But before we get there, we'll do a quick little review of yesterday's stuff as well. So last class, we learned how to determine the characteristics of a polynomial equation given the graph of the function. Now we must begin to work the other way. So now we're going to be given the equation of the polynomial, and we want to try and determine the characteristics. And the way to determine the characteristics is to factor, essentially. That's where we're going, okay? We are going to, by the end of this lesson, be factoring polynomials higher than degree 2. Because in grade 10 and 11, you only ever factor degree 2. Okay, so decomposition or inspection or however you factored, it only worked when it was an x squared or something to that effect, okay? There was a few special cases, but for the most part, it was x squared. Now, what happens if you have an x cubed, or what happens if you have an x to the 5, okay? All these little things that I'm gonna teach you are essentially tools that then we can put together and factor these larger items by the end of class today. So, quick review. For the function p of x equals x cubed plus x squared minus 14x minus 24, and without a graphing calculator, identify the following, okay? So this is right in your notes. Okay, so the type of function, it would be a cubic. It is an odd degree. And remember, yesterday we talked about the fact that that means odd degrees sort of behave like a line and with a bunch of funky stuff happening in the middle. Okay, so when I say sort of behave like a line, clearly they're not a line, okay? But what I'm saying is, if it starts coming in like that, it's gonna come out like that, okay? And then maybe there's some stuff happening in the center, okay? Or it could start up here, coming down, and end going down, okay? Okay. The end behavior of the function, well, my a value is positive, so that means it'll end up. The number of possible x-intercepts that we get from the degree, so that would be a degree, it is a degree 3, so there would be 3 possible x-intercepts. Whether the function will have a max or a min, well, if it behaves like this, and by the way, this is not a degree 3, right? I was just showing you funky stuff that is happening in the middle. As a side note, could you tell me what degree this is? Well, we've got 1, 2, 3, 4 turning points, so this would have to be a degree 5, okay? Anyway, any odd degree that comes in and out kind of in the same general direction, reading from left to right, will not have an absolute max or min value, because the range there will be y as a member of the radius. And then the y-intercept is the constant term, so that would be at 0, negative 24. A reminder, if I ask you for a y-intercept, you have to give it to me as a coordinate pair, okay? Okay. Now, we are going to try to graph it using your graphing calculator. Okay, so I'll give you a second. You can pause me, type that in your graphing calculator. This is the picture that you should have looked at, and we should see x-intercepts at negative 3, 0, and x-intercepts at negative 2, 0, and at 4, 0, okay? And to do that, if we're a Casio kid, we're just going g-solve root. And then if we're a TI kid, we are going y2 as 0, and we're solving for all 3 of the intersection points where that polynomial hits the line y equals 0, okay? Okay, now, determine p of 3. Well, if I want p of 3, I just plug 3 in for x into my polynomial. So when you do that, you should get p of 3 equals negative 30, okay? P of 3 equals negative 30. Now, what does that correspond to? It actually corresponds to an x and a y value together. So it's a point, essentially. It's a point that is on this graph. This tells me when x is 3, y will be negative 30. It tells me that the point 3 comma negative 30 is physically on that graph, okay? Okay, determine the point P of 4, or determine P of 4, I should have said. I shouldn't have said the point there. And what does this correspond to? Well, P of 4 ends up being 0. When I plug in 4 for x, and I do the math, I end up with 0. What does that tell me? It tells me that the point 4 comma 0 lies on the graph, which happens to be on the x-axis. So I've also found an x-intercept here, but we'll get into that a little bit more later on today. For now, it just tells me that when I put in 4, I get out 0, and then that means that the point 4 comma 0 lies on the graph. Okay, very quick review of long division. I know I did this with you when we were trying to find those horizontal asymptotes. So I'm gonna quickly go through this, but just as a very, 10-second review, maybe 30 seconds. We're gonna go 155 divided by 3, and we're gonna say, okay, I need the 3 on the outside and the 155 on the inside. I'm always working my way on the 155 left to right, and I'm trying to get rid of that left number. So I need to get rid of the 1 first. How many 3's fit into 1? None. So now I add the next number. How many 3's fit into 15? That would be a 5. The 5 goes on the top, and then I multiply the 5 by the 3. Okay, so 5 times 3 is 15. Then I subtract and I get 0. Then I brought my other 5 down, okay, to join with that 0, and now I'm asking myself how many 3's go into 5. I'm still trying to get rid of what's on the left. It's just now that I'm working with this leftover piece instead of what the original piece is, okay? So with the leftover piece, I'm trying to get rid of the 5. How many 3's fit into 5? There would be 1. 1 times 3 is 3, and then I have a remainder of 2. So the way I say this is I say 155 divided by 3, that was my original question, is going to be 51, and the leftover bit. The leftover bit is 2 divided by 3. I never got to divide the remainder by 3, and so it'll be 2/3, essentially, that's left over. So you're always trying to get rid of the term in the front. First step would be to say 15 divided by 3 is 5, then multiply, subtract, and see what you have left over. Then you continue the same process with the leftover bit. Okay, and so here's that statement I was just saying. 155 would be 51 plus 2/3. Or in numbers, we just say 51 and 2/3. Okay, so now we're going to do the same thing, and this will feel familiar from when we were trying to find those horizontal asymptotes. It's just going to look a little bit messier. So it's the x minus 3 that goes on the outside, and it's the original question that goes on the inside. When you write the original question, you want to be super careful that you line everything up. You want essentially a column for your degree 3 junk, a column for your degree 2 junk, a column for your degree 1 junk, and a column for your numbers, okay? You also want to make sure that they're in order, in descending degree, and every degree is represented. So say I didn't have that x squared, I'd have to put a 0x squared there so that I had an x squared column, okay? You have to have every degree represented in that descending order. So setting up the question, we would look like this. And now what we're going to do is we're always trying to get rid of what's on the left. So what's on the left is x cubed. I want to get rid of an x cubed. So I'm asking myself, what do I have to put up here so that when I multiply it by that x, I will get out an x cubed? Well, I know that x squared times x would give me x cubed. So I know I have to put an x squared up here. Okay, now the x squared goes on top of the x squared. I'm lining up all my columns together, okay? Now the next step is to multiply. Well, I'm going to multiply the x squared, but I'm multiplying by x minus 3. Don't forget about that minus 3. There's a binomial there. So essentially, that x squared will get distributed to the x and to the negative 3. So that'll be x cubed minus 3x squared. Now what do? I subtract. Okay, be careful with subtraction. What I would always do here is I would stick a big old negative there, like this, and then you say, okay, x cubed subtract x cubed is nothing, that's all gone, and that was the purpose of life. We were trying to get rid of what was on the left, okay? But now look at this, because you have a double negative. X squared minus negative 3x will be 4x. Okay, 4x squared, I should be saying, sorry. And then I can drop the rest of it and keep going. Okay, so I dropped the negative 14x now, and I'm going to keep going. I'm trying to get rid of 4x squared now. So what do I need to put up here so that when I multiply it by x, I will get out the 4x squared and make that disappear? Well, I need a 4x. So 4x goes on the top. I do the multiplication. That'll give me 4x squared minus 12x. Again, watch your subtraction. This will be negative 14x minus negative 12x. So that'll end up with a negative 2x. And then I dropped my negative 24 down. And now I'm working with this leftover bit. And again, I'm always working left to right. So now I'm trying to get rid of the negative 2x. What do I put up top here that when I multiply it by x, I'll get out negative 2x? Well, I need a negative 2 up there. So negative 2 times x is negative 2x, and negative 2 times negative 3 is 6. Okay, now I subtract. Negative 2x minus negative 2x is nothing. Negative 24 subtract 6 will be negative 30, and that will be my remainder. Okay, so if I was to now create a division statement, just like I did with that 155 divided by 3 on the previous slide, I would say, okay, this divided by this will equal this minus 30 over this, because that 30 never got divided by the x minus 3. Okay, so the division statement, when we divide the polynomial p of x by a binomial in the form x minus a, where a is a member of the integers, we can write our result using the division statement as p of x being the dividend, x minus a being the divisor, q of x being the quotient, and r being the remainder. Okay, and so there's our division statement. Okay, awesome. Now, same polynomial, but I want you to try doing it by x minus 4. You try and pause me now and see if you can handle it all by yourself. Okay, so x minus 4 goes on the outside. X cubed plus x squared minus 14x minus 24 goes on the inside. X squared going up top, x squared times x is x cubed, and then that would be minus 4x squared. When I go to subtract, I end up with 5x squared. That's 1 minus negative 4. Drop the negative 14 down. Got to put a 5x up here, so I'll say plus 5x. Gets multiplied. 5x times x is 5x squared. 5x times negative 4 is negative 20. I'm now going negative 14, subtract negative 20, so that's going to be a positive 6. Drop the 24. What do I have to put up here? Well, I have to put a plus 6 there. And when I put a plus 6 there, I'm going to get 6x minus 24. And this is kind of exciting because I get a remainder of 0. Now, that's clean and neat and tidy, but it also tells us something. When we get a remainder of 0, what did we just discover? We just discovered that x minus 4 is a factor, right? The whole purpose of being a factor is that it would divide evenly into the original number, right? 5 is a factor of 30 because 5 divides evenly. There's no remainder when I take 30 and divide by 5. There's no remainder when I take p of x and divide by x minus 4. So that means x minus 4 is a factor of p of x, okay? Now that would be my division statement. All right, so what do these two divisions tell us about the graph? Well, it tells us that x minus 3 is not a factor because I end up with a remainder. And it tells us that x minus 4 is a factor. And knowing that x minus 4 is a factor also tells us that 4 is an x-intercept because all of our factors become x-intercepts in polynomials, right? Think that through. When we had all in grade 11, when you solved for the x-intercepts, you set y to be 0, and then you factored it. And each one of those factors ended up being set equal to 0, and then you knew the x-intercept. So I know I have an x-intercept at 4, 0, because I know that x minus 4 is a factor, okay? So when we have a remainder when p of x is divided by x minus 3. This tells me that x minus 3 is not a factor of the polynomial. We do not have a remainder when p of x is divided by x minus 4. This tells me that x minus 4 is a factor, and now I could write it in this first stage factored form. P of x could now be written as x minus 4 times x squared plus 5x plus 6, because that was what was left over. It's just like taking 30, dividing by 5, and saying, okay, 30 can be written as 5 times 6. And p of x can now be written as x minus 4 times x squared plus 5x plus 6. But then you can imagine when you see x squared plus 5x plus 6, your little heart starts going pitter patter, because you're thinking, hey, I can keep factoring that guy. I could break that guy down, right? Well, actually you can't, because it's not factorable, but sorry, yes it is. What am I saying? 2 and 3. I could break that down into x plus 2 and x plus 3, right? Well, now I know 3 x-intercepts, and I can factor a polynomial of degree 3, okay? And so somehow, when we have a polynomial of degree 3, we just need to try and find that first factor, and that's what today is going to be all about, is how do you get to that first factor, okay? All right, so that was long division. Now I'm going to talk to you about synthetic division. Now, what does synthetic division mean? What does the word synthetic mean? Synthetic means fake, right? If you bought, I don't know, synthetic leather, do you buy synthetic leather? I don't know, but synthetic means fake. It means it looks like the real thing, but it's not actually the real thing. We can use a process called synthetic division to divide polynomials. It allows you to determine the quotient and the remainder without writing all the variables. So it's quicker. And it works well as long as the coefficient on the binomial is 1, okay? If you're heading to calculus, I want you to be very, very comfortable with long division. We don't use synthetic division in calculus much, but for 30-1, this is perfectly acceptable when you're trying to divide things out. So I'll quickly read through the steps. Most of you are going to read through these steps and say, this sounds so complicated, but if you just let me get through the steps, and then we're going to do it together. And as we do it together, it'll make more sense too, okay? So write out the coefficients of each term of the dividend, make sure all the degrees are represented, and the sign in front is included. On the outside, we use the value for x that would make the factor 0. Bring the first term down, multiply by the divisor, place under the second column, add the second column, and repeat the process. The numbers on the bottom are the quotient with 1 less degree than the dividend, and the number in the bottom right-hand corner is the leftover bit, or otherwise known as the remainder. Okay, so what did that mean? What does all that look like? Well, here's what we're going to do. Okay, we're essentially going to do the same 2 questions we just did. Okay, we had taken that original polynomial, and we divided by x minus 3, and we divided by x minus 4. So we're going to go through that process again, but this time I'm going to show it to you with synthetic division. Okay, so you essentially have 3 working lines here, okay? You've got this line, which is the question line, and then you've got this line, which is the working line, and then you've got this line, which is the answer line, okay? And then out here goes what you're dividing by. Now, it's the number that would zero the factor out. So what value for x here zeros that out? That would be a 3, okay? So we stick a 3 out there, and then we're going to stick the coefficients of this guy right in here, okay? So when we do that, that would look like this. Whoops. Take that ink off for you. Okay, so we've got 1, 1, neg 14, and neg 24. And then we've got a 3 on the outside. Now, the first guy, the first number, drops right down to, like we skip the working line, we drop right down to the answer. So there's going to be a 1 there, okay? Then the 1 gets multiplied by the 3 and gets placed in the next working column, okay? So 1 times 3 is 3, and then we add. 1 plus 3 is 4. 4 times 3 is 12, and then we add. Negative 14 plus 12 is negative 2. Negative 2 times 3 is neg 6. Negative 24 plus neg6 is neg30. Now, if you were following those steps, we said that this is the quotient dropped a degree. Okay, so I started with an x cubed. So this begins with an x squared. So that's going to be x squared plus 4x minus 2. And then this fella is my remainder. Okay, so then I can say minus 30 over x minus 3 if I was writing that division statement. Okay. And that makes sense that we drop a degree because we're taking a degree 3 polynomial and dividing by a degree 1 polynomial, right? When we were dividing powers of the same base since like grade 8, you know, x cubed divided by x is going to give me x squared, right? So it makes sense that we're going to drop a degree there. Okay. So x squared plus 4x minus 2, subtract the remainder of 30 over x minus 3. Just for clarification there too, I am subtracting because it was negative 30 here, right? If it was positive 30, I'd be adding that remainder. Okay, so now let's try the x minus 4. You pause me and see if you can do it by yourself. I have you all set up. 4 goes on the outside because that's what 0 is the factor out. 1, 1, negative 14, negative 24 on the inside. Okay, and again, I'm going to drop my 1, multiply. So 1 times 4 is 4. Add 1 plus 4 is 5. Multiply 5 times 4 is 20. Add negative 14 plus 20 is 6. Multiply 6 times 4 is negative 24. And then add negative 24. Negative 24 is 0. That should say positive 24. Sorry about that. I can fix that for you right now. That should say, whoops, positive 24. Okay, so negative 24 plus 24 is 0, and then that's where I get my remainder of 0. Okay, so I end up with x squared plus 5x plus 6 with no remainder. Okay, so we have talked about long division and synthetic division. So these are two different ways to divide a polynomial by a polynomial. Splendid. Okay. If the remainder was 0, what does that mean about the divisor? We've already talked about that. It means that the divisor is a factor of the original polynomial. If the remainder is not 0, what does that mean about the divisor? It means it's not a factor. Now, you can imagine then that the remainder is very important to us, right? Because it's the remainder that tells us whether we just found a factor or not. So wouldn't it be nice if all we needed was the remainder? Wouldn't it be nice to do this a little quicker, even quicker than long division and quicker than synthetic division? What if we didn't care what the answer was yet? What if all we cared about was to know whether the remainder was 0 or not? Okay, that enters the next thing for us to talk about. Okay, so we've determined P of 3 and P of 4. What were those answers? Well, P of 3 was negative 30 and P of 4 was 0. And what I want you to notice is those are the remainders that we got. When I divided by x minus 3, I got out a remainder of negative 30. Look back at your notes there. When I divided by x minus 4, I got a remainder of 0. And so if I just plugged that number into the original equation, it would give me out the remainder. And that's called the remainder theorem. Okay? So when I solve for P of A, I get out the remainder if P of A was to be divided by x minus A. So whatever I'm dividing by, that value for x that would zero that factor out, if I plugged that in, it will always give me out the remainder. Now, it is also always giving me out the point that's on the graph, right? But that y value actually represents the remainder of the polynomial, or of that polynomial division, okay? It's a really, really cool connection. Okay, so the factor theorem and the remainder theorem. When a polynomial p of x is divided by a binomial x minus a, if p of a is what, then it is a remainder. Well, if p of a is any number but 0, then it's a remainder. But if P of A is 0, then it's a factor, okay? So the remainder theorem and the factor theorem are essentially the same theorem. The remainder theorem says if I plug something in, I'm going to get out the remainder. The factor theorem essentially says if I'm using the remainder theorem and I get out 0, then I found a factor, okay? So these theorems provide us with a much simpler way of finding the remainder or factor than doing division. Remember, we're really finding points on the polynomial as well. Okay, so what is the relationship between the divisor from long division and what we let x be in P of x? So we are always, I've said a couple times, whatever zeroes that factor out, right? We let x be whatever causes the divisor to equal 0. So what if we were dividing P of x by x minus 1? What would we let x be? We'd let it be 1. What about 2x minus 3? We'd let it be, what's the value for x that would zero that guy out? That would be 3 over 2. Okay? Okay. Using the function P of x equals x cubed minus 4x minus 9x plus 10, determine P of negative 2 and P of 4. You should pause me and try these yourself. Give you a moment. Okay, you should have gotten that P of negative 2 was 4. So, question, is x plus 2 a factor? And the answer is no, it's not, right? Because if it was a factor, I would have gotten out 0. P of 4, when I plug that in, I get out negative 26. So is x minus 4 a factor of this polynomial? No, it's not, okay? So what are your answers telling you? You have not found factors. Okay, so if I divide P of x by x plus 2, I will have a remainder of 4. It tells me that x plus 2 is not a factor of P of x. Same thing, if I divide P of x by x minus 4, I will have a remainder of negative 26. It tells me that x minus 4 is not a factor of P of x. Okay, good. All right. When 2x to the 5 plus x cubed plus kx squared plus 3 is divided by x plus 2, the remainder is negative 37. Determine the value of k. Okay, well, this is just using the remainder theorem. I don't need to long divide this. I don't need to synthetically divide this. I just need to use the remainder theorem. I know that I am dividing by x plus 2, which means I can plug in negative 2 for x and get out the remainder. Well, I know the remainder. The remainder is negative 37. So that gives me a cute little algebra equation so I can solve for k. So go ahead, solve for k. We're going to clean this up. I assumed you paused me and now you have the answer. That's how this goes, you know. Okay. Sorry, I'm looking out my window because there's robins that keep flying around and I'm not sure what they're doing out there. But okay, so starting to clean this up, negative 2 to the 5 is negative 32, times 2 is negative 64, negative 2 cubed is negative 8. Clean up the numbers on the right side, I get negative 37 equals negative 69 plus 4k. Bring the 69 over, add 69 to both sides, divide by 4, you should get k equals 8. Awesome. Okay, state the value of b if x plus 4 is a factor of 3x cubed plus bx squared minus 6x plus 40. This is essentially the same question. It's just instead we said that it was a factor. So if it's a factor, that's a fancy way of saying the remainder is 0. Yeah. You guys are not as excited as me. I can just tell. Okay, so p of negative 4 will equal 0, which means I'm going to plug negative 4 in for x, and I'm going to set my equation equal to 0, and I'm going to solve for b. So pause me and go ahead and do that. Cleaning it up, you end up with b equals 8. Now, please don't think that the answer is always 8, just because the last two answers were 8. That's just coincidental. Okay? All right, so here we go. Completely factor P of x equals x cubed plus x squared minus 14x minus 24 without using a graphing calculator. Now, when we say without using a graphing calculator, we're saying you can't use the graphing portion. I'm not saying we're going to take your calculator away from you. If you want your calculator for 2 plus 2 equals 0, that is totally fine. But it does mean that we don't want you to actually graph this. We want you to try and find an algebraic process. Now, we are going to use your graphing calculator to help us find a factor quickly. Okay, and here's the easiest way to do it. What we need to do is we need to test essentially factors of negative 24. So I'm going to go P of 1, P of negative 1, P of 2, P of negative 2. I'm just going to kind of keep going through that list until I find one that equals 0. Now, I'm just going to switch what I'm sharing with you for a sec. We're going to switch to a graphing calculator if I have the ability to do that. Just a sec. Yes, I do. So stay with me. Okay, so what I want you to see here is the following. So my original equation was, okay, so what I'm gonna do is I'm going to store 1 in for x, okay? And so how I do that is I go 1, and then I press this arrow button here, okay? Store as, and then my variable x, okay? And then I get back 1. Now, what I've just trained my calculator to do is every time I press x, it's gonna be 1. Now, TI kids, you can do the same thing. Your store button actually says STO, and it'll be down on this, this column, somewhere down here for you, okay? Now, I'm just gonna type that equation directly in. So x cubed plus x squared, oh, I gotta get out of there though, plus x squared minus 14x minus 24. Okay, and I get out negative 36. So I know that x minus 1 is not a factor. Okay, now why would I have done that? That seemed like it took a long time. Because watch what I can do. Now you can do this on a black Casio or a gray Casio. I'll talk to the TI kids in one sec. If you can actually go up and edit it. So you can come here and just go negative and then hit enter and it will update itself. Okay, so now I know that x plus 1 also isn't a factor. And then I can come up here and switch it to 2. And that's negative 40, so that doesn't work. And then I can come up here and go negative 2, and I get 0 right there. Okay, so when I plug in negative 2, I get out 0, which means x plus 2 is a factor. So I just found my first factor. Now, TI kids, if you have a newer TI, what you can do is you would store the x, just like we were talking about, and then type your equation in, right? Then you would store x again here. So let's say you want your next one to be 2. So I'd go 2 store as x, okay? And then all you have to do if you're a new TI, go up to that equation and hit enter. And what that will do in a TI is it'll copy it right down to the bottom for you. And then if you hit enter one more time, it will get you the new number, okay? If you have an older TI, second enter will bring back past entries that you've done, and it'll bring back the last 10 entries you've done. So you could do it that way as well, okay? So it's just a quick way to help you get through the math to find that first factor, okay? So now I'm gonna switch back to my PowerPoint so that I can show you what I've written down here. Okay, so now, first we need to find a factor, test using the remainder and factor theorem. So that's just kind of what I did on my calculator with you. So P of 1 was negative 36, that's what we saw. P of negative 1 was negative 10, P of 2 was negative 40, P of 2 is 0. And right there we can stop. P of 2 is 0, I have now found a factor. Now you need to tell me that you know you found a factor, because remember all of this is about communication. So P of negative 2 equals 0, therefore x plus 2 is a factor, okay? Now, what do I do with that? Well, here's where long division or synthetic division kicks in. Because now that I know it's a factor, I know that I can divide the polynomial by x plus 2, and I'm gonna get out a polynomial that I can continue to work with, okay? So I'm gonna use synthetic division. So I have -2 on the outside. I've got 3, 2, 1, nothing. So I have all my degrees represented there. 1, 1, -14, -24. Drop the 1, multiply by -2, add, multiply by -2, add, multiply by -2, add, and I get a remainder of 0. Now, if you don't get a remainder of 0 here, something went wrong, right? Because you just told me 2 seconds ago, you just wrote down in your work, hey, I found a factor. So if you found a factor, the remainder has to be 0. If the remainder is not 0, stop and figure out what just went wrong. Don't keep going, right? Okay, so here we are right now. We're saying P of X so far has been factored into x plus 2 times x squared minus x minus 12. That's where this comes from, okay? I want to see this intermediate step. This is the first multiplication sentence you've created. But now we always want to completely factor. You see that up here? It says completely factor. That means factor as much as you possibly can. So now I'm looking at that x squared minus x minus 12, and I'm saying, okay, let's factor that. Can you tell me two numbers that multiply together to give you -12 and add together to give you -1? And they are -4 and 3. So now I have completely factored, okay? Now, you have a graphing calculator in front of you. You could have graphed this and found the x-intercepts and went right to the answer. So what I need you to hear from me is this is all the stuff you have to provide to me to algebraically have shown me your work. Okay, super important that you are communicating how you are determining these things. You can't just graph it. I mean, you can graph it and check your answer if you want, but you can't just graph it and give me the factors because that's not going to be worth anything. You have to have stuff to back it up, okay? Okay, the integral zero theorem is just a fancy way of saying if I'm trying to find that first factor, I look at factors of the constant term, okay? So if x minus a is a factor of the polynomial function p of x with integral coefficients, integral just means integers, by the way, then a is a factor of the constant term. So for instance, in this one here, I have a -6 on the back. Well, I'm not even gonna try p of 5 then, because 5 is not a factor of -6. I would only try factors of the constant term when I'm going through that p of 1, p of -1, p of 2, p of -2, okay? Okay, good. So let's do one more together. We're going to completely factor x cubed plus 5x squared minus 8x minus 48. Okay, x cubed plus 5x squared minus 8x minus 48. So you got to find a factor first. So try p of 1, try p of 2, try p of -1, try p of -2. Okay, you're not going to try p of 7 here because 7 is not a factor of -48. You follow me? Okay, go find one. So p of 1 was 50, p of -1 is -36, p of 2 is -36, p of -2 is -20. Some of you are shutting down now because you're like, this is too hard. It'll come. They always come. Don't worry. P of 3 is 0. See, that didn't take long. P of 3 is 0. So what's my factor? My factor is x minus 3. Tell me that. Communicate to me what just happened, okay? So p of 3 equals 0. Therefore, x minus 3 is a factor, okay? All right, so here I go. I'm going to divide out my x minus 3. I'm going to do synthetic division again. If you want to practice using long division, that's great too. Drop the 1, multiply, add, drop, multiply, add, drop, multiply, add. Okay, and so my intermediate factoring here, my first kind of factoring process has rendered p of x to now be x minus 3 times x squared plus 8x plus 16. That's what I got out. Okay, now I'm looking at that x squared plus 8x plus 16, and I'm going to try and factor that, and I know that's x plus 4 times x plus 4, which is x plus 4 all squared, which is super cool because now I have a visual of what that looks like based on yesterday's lesson. I can say, okay, now I hit the x-axis twice, once at 3 and once at -4. The 3, I have a multiplicity of 1, so I'm going to go straight through. And then the -4, I have a multiplicity of 2, so I'm actually going to change direction. So you can see how all of this is going to fit together really, really nicely. Okay, completely factor, p of x equals 4x squared minus 17x squared plus 4. The robins just flew again if you watched me look away. I'm sorry. Focused. Okay. Okay, so this one's a degree 4. So in theory, you'd have to find a factor, divide it out, and that would drop you to degree 3. Then you'd have to find another factor, divide it out, and that would drop you to degree 2. Then you can go back to all the rules you learned about factoring degree 2s. But you don't have to do that here, because this is special like my mama told me I was. Brown bear, what do you see? Do you remember that book? Anyway, I see a special trinomial looking at me. You get what I was trying to do there? Okay. This is a special trinomial because there is no x cubed here. And so look, the exponent in the front is twice the exponent in the middle, and then there is no variable in the back. So I can actually just go through decomposition like I would with an x squared and an x term. And that will work here. Okay, looking for two numbers that multiply together to give you 16 and add together to give you negative 17. So that would be negative 1 and negative 16. Factor the front two, factor the back two. I see a common factor of 4x squared minus 1 there. I'll pull that to the front, and I have 4x squared minus 1 and x squared minus 4. Now I'm completely factoring. So I also see here that both of these are differences of squares. 4x squared minus 1 will factor into 2x plus 1 and 2x minus 1. X squared minus 4 will factor into x plus 2 and x minus 2. And so my final answer would be 2x plus 1, 2x minus 1, x plus 2, x minus 2. I factored it into 4 different factors, which makes perfect sense because I started with a degree 4. Okay, isn't that fun? Ah, super fun. I love this lesson. Okay. So let's summarize. The factor theorem and the remainder theorem are essentially the same thing. They are useful ways to determine points on our polynomial. The remainder theorem tells us if p of x equals any number but 0, we have a remainder. This is still a point on the polynomial. The factor theorem tells us if p of x equals 0, then what we have divided by is in fact a factor. The easiest way to tell what values we should try to substitute in for x is to look at the x-intercepts of a graph, and we can use these values to divide. But what I want you to do from an algebraic perspective is to try some of those. Go that p of 1, p of negative 1, p of 2, like I showed you, okay? If the degree of the polynomial is larger than degree 2, we will have to divide until we reduce the polynomial to a degree of 2. And then once we've done that, all our other factoring rules will kick in. Okay, all right, my friends. So this is what you guys are going to try to do, and go through it. Make sure you're neat, make sure you're clear, make sure your communication is concise, and make sure you ask me lots and lots of questions. Okay, we'll see you soon. Have a great day. Take care.